Welcome. Today we're going to be talking about the data-driven occupancy load workflow using Revit, which is part of our Evolve Lab code tools. So data-driven basically means that we're using data from the model and from the user, and we're using it to drive the process of finding our information we want to place on the code tools. And I also want to mention that this process is all done inside of Revit. We are not using any add-ins or special dynamo graphs or anything. Everything is based on native Revit features.
All right, thank you, Clara. So before we jump in, we'd like to introduce ourselves and tell you a bit about who we are. So we are Evolve Lab. Evolve Lab is a company we began in 2015 as an on-demand computational design and BIM consulting firm. Today we're comprised of licensed architects, BIM managers, design technologists, and developers. We specialize in automation and interoperability products, such as some of our products which are currently in development: Helix, Glyph, and Evolve GD. We do a lot of custom app development, as well as BIM support and training, and computational design as well.
So my name is Clara Fontiboa. I studied architecture, urban design, and landscape architecture at the Universidade Federal de Ouro Preto in Brazil. After that, I have been in the architecture field for 7 years. And the past 3, I have been at Evolve Lab as a design technologist, where I mostly work with BIM management, Dynamo, and some live coding using Python and some C#. And I also help the app development team at Evolve Lab with the UI and UX design. On a more personal note, I also like to do some Lego creations these days, where I create these custom builds that are inspired by architecture.
All right, thanks, Clara. And my name is Jim Grieve. I am a BIM manager at Evolve Lab. I have about 20 years design and production experience in the AEC industry. I began my career as a general CAD tech and have moved through different roles to be a BIM manager. Through most of that time, my focus was on architectural design, but I have had the opportunity to work on many different types of projects, including multidiscipline design. So I've been able to see projects through different lenses, which has been great. I've also spent a lot of time working with point clouds as a terrestrial LiDAR specialist and specializing in software such as Autodesk Recap. With Evolve Lab, I've been with Evolve Lab 7 or 8 months as a BIM manager. My focus has been client relations, doing BIM training and BIM consulting. On a personal note, I am a collector of various music gear, and I typically say I don't have enough time to use most of it, but I do get out every now and then and play an acoustic gig from time to time, which I really enjoy. Next slide. Okay, so why are we here? I'll just go ahead and kick us off. In this class, we will be focusing on the implementation of automated code analysis and documentation within Revit, including occupancy classification, which is covered in the International Building Code, Chapter 3, and the number of occupants calculation, which is driven by Chapter 10. We will cover a bit about how Evolve Lab has created a package of custom components that we've named code tools. Next slide. So at Evolve Lab, we work with a lot of clients, and one request we've received frequently is the need for a better standard for creating code drawings within Revit. So this need led to the design of code tools, which was created to assist in that calculation and documentation of building code analysis. As it currently exists, it supports 2012, 2015, and 2018 International Building Code. Included in these tools are complex customized schedules and tags, which are loaded with complicated equations. We have custom filters, view templates, fill patterns, color fill schemes, of course, shared parameters, and then some other out-of-the-box tools, such as the very powerful Path of Travel tool, which was introduced in 2020. So in this session, we're going to talk about each one of these items, give a very basic definition of how they work in Revit, and then mostly we want to show how we've combined complex calculations with these out-of-the-box Revit tools to streamline these code analysis tasks. Next slide.
All right, so how do the code tools use Revit? So the code tools use 5 major features in Revit. It uses the room and the area elements, the schedules, the tags, shared parameters, and calculated values. So room and area elements are treated here on this process as the cookie jar or the containers that store all the data that we want to use. The schedule is the major user interface that the architect has to input the data that they need and to check and make sure that the calculations are going through correctly. The shared parameters is a special type of parameter that helps synchronize the whole process. So it links to the schedule and the tag and the calculated values, making sure that everything is matching. So the tag and the rooms and the schedules are all sharing the same data, and they are not manually input separately. And last, we have the calculated values, which is the brain of the process, which is where we place our formulas to calculate all the values with the inputs and then return the results that we need on the tags, in the schedules, and in the plans.
All right, so how do the code tools use these out-of-the-box Revit features? So as Clara mentioned, we work with rooms and areas. And the first step in this process is to define the spaces of your building. To do that, we use the rooms and areas. So let's start at the very beginning, very basic definition. What are rooms and areas? A room is a subdivision of space within a building model based on room bounding elements such as walls, floors, roofs, and ceilings. An area is a subdivision of space as well within your building model, but typically on a larger scale than individual rooms. Areas are usually made up of several rooms. So again, as Clara mentioned, rooms and areas are like the containers that host data related to a specific portion of space in the project. Data such as name, number, and square footage. So in our process, we say rooms and areas are like the cookie jar, holding all the delicious data that we all just want to get our hands on. So when you use code tools, you can go to the next slide. You can pick rooms or areas as the containers. Each has its advantages and disadvantages. Rooms are typically easier and faster because you can quickly place them on in your model, and they will detect automatically any room bounding objects such as walls. You can place them in a floor plan and annotate them upon placement. So rooms are usually a faster option. But then on the other hand, there are areas. You can go to the next slide. Areas are very versatile. When you use areas, you have to define the boundaries. It's not looking for a component within Revit that's room bounding. So they're very versatile for that reason, but you also have to manually create those boundaries. Other than exterior walls, which you see in the video, Revit prompts us, do we want to use exterior walls as a boundary? And I said yes. But then you can see I'm adding more boundaries here just by selecting the walls and modifying one to extend to the end. And so now I can start placing my areas, which will encompass multiple rooms. Another great thing about areas is you can have multiple different areas and different boundaries within the same model. So it's up to the designer to decide which is more appropriate for their project and what scenario, which option they'd like to use when using this workflow. Next slide. So in this example, I'm looking at a room. When I start to place these rooms in the model, the code tools wants me to populate the built-in room parameters. Those are occupancy use, space function, which code year we're working with, and whether or not it's on an egress path, on a path of travel. Next slide. The occupancy use and space function keys are a system of values which we set up that reference the IBC and show and allow our calculations to function. So I can fill out these parameters in properties as I was showing in that previous example, or we can change them directly in the schedule. So that brings us to our next topic, which is schedules. And again, I'll give a very basic definition here. Revit schedules are usually created because there's a need to quantify the various elements in your Revit project. Revit schedules are a lot like a spreadsheet, consisting of columns and rows and cells which contain various data regarding to Revit elements. You can use formulas and parameters. Formulas inside the parameters can be applied to calculated new values from existing ones. So building components schedules can list all instances of components in your project. When you're using the code tools, the schedule becomes the main user interface for the designer. So the designer can come to our schedule and begin to interact with all the tools. All of the data that's entered will be contained in the rooms or areas and easily accessed through the schedule. So to help with that interaction, we created two different schedules. One's a QA/QC schedule and one is a documentation schedule. So you can go to the next slide. So this is an example. This is the QA/QC schedule. This is where the architect or designer goes to input the data and review any calculations and confirm the results. The schedule populates automatically when you define some important information about your rooms or areas using these built-in custom parameters. Next slide. Since these schedules and tags are set up using complex formulas, we have developed numerical keys, which represent the occupancy classification and function of space. These keys are defined in these two schedules on the screen now. These are documentation schedules for the user to reference. Next slide. So as you'll see in this video, once the user begins entering this information into the schedule, it will auto-generate the values based on first the IBC year that you selected. To help with this process, the schedule uses conditional formatting and colors to guide the user. For example, the code year turns green whenever an invalid year is entered. The manual occupancy load factor will turn orange whenever a manual value is required. So in this example, you can see I'm entering gross area. The schedule also wants to know if each room is on an egress path. And if so, the purple cells are telling us that we need to enter the number of additional occupants. These colors in the schedule are also tied back to the documentation for reference, and the rest of this information will be generated for you. So once we're done with the QA/QC schedule, we have this documentation schedule, which is on the screen now. This is not color-coded. This does not show all the information that the QA/QC schedule shows. All of the working fields and calculations are hidden. So this is the schedule that is kind of the presentation schedule to be placed on a code review drawing. All right, next slide. And this brings us to our next component in the workflow, custom intelligent tags. So what are tags? A tag is an annotation for identifying elements in a drawing. Since Revit allows us to embed our data directly into components that we are modeling, we just need a way to access that data. Therefore, we use tags. So when a tag is created, labels are added to display the value of a desired parameter. These labels display the values for the component's corresponding parameters after the tag is loaded and placed in the project. So tags can be placed on the same component across different views. And because the data lives in the component, that tag, the information the tag is showing will always be consistent information. Okay, next slide. So how does Code Tools use tags? As was mentioned before, the user enters the data into the rooms using, the QA/QC schedule. This data is now embedded into the rooms and can be extracted using our custom room tags. These tags display all the information about occupancy and function of space. This is accomplished by populating the custom tags with the same parameters and calculations that are populated in the schedules. So since the schedules and tags are using the same parameters and calculations, the values will always match up. Next slide.
Right. So now that Jim showed us all these features that the user interacts with directly in Revit, we're also going to talk about some of these extra features that are in the back and actually making the whole tool work as a whole. First, we have the shared parameters, which we mentioned before exists in a separate file, and you can link those parameters to your project and to your families. So different than the custom, the more used project parameters that you insert from your project, or the family parameters that you create from inside of your family, the shared parameters can exist on both. And once you place that shared parameter on both, the project related to a category, which in this case is the room and the area elements, and then you place on a family, which in this case is the room and the area tag, then that data flows between the project and the family, making everything synchronized and dance in the same place, in the same pace. So here we can see how you go about on adding the shared parameters to your project. First, you select the categories and you go and add your parameter, and then you add that parameter to your schedule. And once you do that, you go to your family and you also go to this exterior file, add your parameter there. And since you pick the same parameter, they are going to be synchronized now. So once we load that family, we can see that if you change the information from the elements, we can see that the tag also updating that information. And if we go to the schedule, we can also see the same information. So it is always the same information since we are using shared parameters. That is the power of the shared parameters. So next, so once we have these shared parameters synchronizing all the families and the project that we are using, we then use the calculated values to create those equations that we need to get the inputs that we place, the inputs that the room and the elements also place, such like the area, and make all the necessary calculations to return us the values that we want to show in the tag and in our code plans. So here I first have one example. This is the occupancy group formula. As you can see, is a very, very long formula and is using an if statement. So basically what this formula is doing is related to this table we have on the site that we created. It takes the occupancy key. So the user go there and say, this area is the occupancy key 1.01. And the formula then says, oh, if the occupancy key is 1.01, then the occupancy classification is assembly. And then it keeps going and going and going for every single row until we reach the end. And if the user inserts a value that is not in the table, it returns the TBD, and you can see the TBD right at the end of our formula here. So a little bit about if conditions. If condition is one very useful formula that we can use in Revit, and it takes three values. It takes the condition, in this case, as you can see on the top. And let me use this tool here. So if we go here, you're gonna see it starts with the if, then occupancy use key equals 0.1.01. So this is the condition. Once we establish that condition, it's gonna see what the user inputs. So they can input yes, they can input any value there. So if the value equals to this condition, and it returns assembly. If not, it returns something else. So three conditions, right? But in this case, because we have many conditions, we replace the false value with a new condition. And then we replace until we get to the end. So the only false value we have at the end is the TBD. And you can see how many conditions we have and how long that formula got to go over the whole schedule here. So next we have the occupancy load factor parameter. And first I want to talk a little bit about how you go about on adding a calculated value to your project. So here we are at the schedule, and we go to the field to edit it, and it opens the schedule property pop-up with the fields tab open. Normally, when you're adding a parameter, you just pick one here, and then you send it to your schedule, right? And here are the fields that we have on the schedule. But on this case, since it's not an input parameter, it's a calculated value, we use the FX button to open a new pop-up for the calculated values. And here we have three things that we always have to pay attention. We want to define a name, which is a new name that no other parameter is using. We want to define the type, which is basically the unit that parameter is going to return. In this case, we want an integer, which is like a whole person. We don't want a half a person. We don't want a text. We don't want a length. We want an integer, a person. And then we have the formula here. In our formula, it's a much simpler formula than before. We have the area being divided by the occupancy load factor. That is basically the calculation. It's dividing one number by the other, but we also round up that number because we want a maximum value. So if it returns 8.3, we don't want to return 8 or 8.3. We want a full person, which is 9 and which is higher than the number, the partial number. And we also divide it by 1 feet twice. Why? This is because we want to return an integer, and we are getting an area and dividing it by another integer. So we need to divide it by length twice to turn an area into an integer. Another detail that I want to point out too is that to help you build your formulas, you can click on this button and see all the available fields from your schedule that you may be able to use on your formula. Once you place that form, once you click OK, and you have that field added to your schedule, you're gonna see that new column on your schedule. So how do all the features work together? So just as a recap of what we already discussed, we learned that we have the shared parameters, we have project and the tag. The shared parameters link both of them together, making sure that it synchronizes. We have the calculated values, which sometimes is multiple calculated values that get combined together to return the value that we want in the end. And to start the process, we always have some inputs from the model. In our case, we have the area and some user inputs, which are the keys to start the whole process of identifying those spaces specification. So what is the code tools calculation process? Now I want to go a little deeper and show in more detail all these parameters and how they relate to each other. So in this diagram here, we see the code review schedule on the bottom, and we see a diagram that represents those parameters and how they relate to each other. With the few colors, we have the user input or all the inputs, which is the user input, and the area as well being inputted, and then the squares with only the outline, we have the calculated values and how they work together until we reach the end. So for more clarity, we have an extended version of this diagram. And here we can see the code year influences in theory both the occupancy key and the function of space. But the occupancy key doesn't change between the three year of the code. So the occupancy key doesn't really get modified by the code year as the function of space does. So once the user inputs the occupancy key, as we mentioned before, the keys are in this schedule. Then the tool results on the occupancy group key and the occupancy group, which is assembly A-1, assembly A-2, and so forth. So we have all the available options. All the user has to do is insert the key. Similarly, we have the function of space, taking the information from the space usage and occupancy load table, which is related to the chapter 10. In this case, we have an influence of the year. So depending on the year, the certain options exist or not. And once we define that, we return the function of space. As an addition, the function of space sometimes is not defined by the chapter 10 table. And in this case, the user needs to know a little more of the code than the code tools know, and they would insert those values manually for what the occupancy load factor is and whether it is a net or gross factor. Once the user define all that, then the code tool kicks in and calculates the occupancy load factor and the net gross, which is the first step to get us to the number of occupants, right? So as we saw in our formula earlier, we have the number of occupants defined by the area, which comes directly from the model. The user doesn't need to know that, and divides it by the occupancy load factor. And all the way at the end, we have the number of occupants cumulative, which is giving space for egress in other areas that is part of the path of travel to other rooms or areas. So you also have the input of the path of travel, and if that specific space is the path of travel, you can then insert the value that you can see from other rooms. Oh, I know that 3 people are coming from here, or 4 over here. So you can add that value on the number of occupants addition. And with that, we get the cumulative occupants calculation, which adds the addition to the occupant that was automatically calculated. All right, so this sums it for the code tools large portion that we wanna cover in detail, but we also wanna show you some extra tools that we have on our toolbox. So the first one is the color legend. So we just went ahead and also color coded the plans. So we have this function of space special legend created that you can insert on your plans to identify the color of the rooms. We also have the path of travel. This is using the out-of-the-box 2020 release first in 2020 Revit that creates the path of travel automatically. And for our tools, what we did was create some custom line styles and some custom tags to help you customize your plans. And finally, we also have a filter override that is embedded on the view templates. So those filter overrides identify the fire rating information of your walls and apply a custom fill pattern to identify them. So we have a custom fill pattern for the 3 hour, 2 hour, 1 hour, and smoke partition.
All right.
Back at you, Jim.
Thanks, Clara. Okay, so just a quick recap of what we have learned today. You can go to the next slide. So we've learned just some basic definitions and gone over a bit about rooms and areas, how we're integrating those into this workflow. We've learned a bit about schedules and custom tags and the shared parameters and calculated values, which are incorporated in those to get this result. You can go to the next slide. And we also learned a bit about how we have used this workflow and how it uses all of these features to facilitate the production of code tools and code analysis. All of these components come together as out-of-the-box Revit features to create a more automated code analysis workflow. And this is a workflow that allows the designer to enter just a minimal amount of information and quickly have an accurate code review drawing as a result. Next slide. Just before we finish up, we wanted to mention a free pick on Flat Icon website. And we used a lot of these icons in our presentation. So thank you for that. And we'd be happy to take any questions that anyone might have. Feel free to reach out at any time. And thank you for watching this today.